Day 347 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 38, count and say. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. The count and say sequence is a sequence of digit strings defined by the recursive formula count and say 1 equals 1. Count and say of n is the run length encoding of count and say n minus 1. Run length encoding RLE is a string compression method that works by replacing consecutive identical characters repeated 2 or more times with the concatenation of the character and the number marking the count of the character's length of the run. For example, to compress the string 3322251, we replace 33 with 23, we replace 222 with 32, we replace 5 with 15, and we replace 1 with 11. Thus, the compressed string becomes 23321511. Given a positive integer n, return the nth element of the count and say sequence. All right, y'all. Now that can seem a little bit confusing just by reading the problem. So let's go ahead and take a look at these examples. Now, once we go through these examples, I feel like it should make way more sense. So let's get started. So in example 1, we have the input n equals 4. The output equals the string 1211. So first, what they want us to do is they want us to find the fourth element in the count and say sequence. The explanation gives us the count and say sequences for 1 through 4. So let's go through it. So count and say 1 is 1. That's always going to be the base case. So we're going to start with 1. So then we go to count and say 2. The RLE of 1 is 1, 1. Why? Because there's only 1, 1. So the RLE of 1 is 1, 1. We put 1, then 1 for 1, 1. Then count and say 3, we want the RLE of 11, right? Or 1, 1, but in this case it's 11 because 11 has 2 1s, right? So we're just counting the 1s. So we put 2, 1 because there's 2 1s in this 11 right here. Boom. Now we come to count and say 4 has we want the RLE of 21 or of 2 1s, right? So if 21, that means there's 1, 2, and there's 1, 1. So we come over here, we put 1, 2, and 1, 1 because there's 1, 2 and 21, and there's 1, 1 and 21. So we put 1, 2, 1, 1. So let's just go through it one more time to make it make sense. We start with 1. There's only 1, 1, and 1, so we put 1, 1. Boom. Then we come down and we do the RLE of that 1, 1 or 11. So in 11, there's 2 1s, so we put there's 1, 1 here and there's 1, 1 here. That equals 2 1s. So we come over here, we put 2 1s. 2 for the number of ones and 1 for the number, right, that we're referring to. We're referring to ones, so we put 2 1s. Boom. Then we come down here with the 21. There's 1, 2, and there's 1, 1. So we come over here, we put 1, 2, and we put 1, 1. We're just keeping count of the number of 2s, and we're keeping count of the number of 1s. So we put the count in front of the element. So we put 1, 2, 1, 1. So I know that sounds simple enough. Let's go ahead and take a look at example 2 where they might try to throw a trick question our way and where n equals 1. So in the input n, in example 2, input n equals 1, output is 1 because that's the base case. As you can see, count and say 1 is going to be equal to 1. So we don't have to find the first element of the count and say sequence will always be 1 because this is the base case. So that's why the output is 1 because it's just the first element of the count and say sequence. Whereas up here, we wanted the fourth element of the count and say sequence. So now that we understand the question, y'all, let's get into the fun part, actual code. Code is not that difficult to understand at all. So let's get started. Now, the first thing we're going to do is we're going to create a helper function recursively that's going to help us solve that. So we need to come inside this main function. We're going to create our helper function inside the main function by saying func. We could just call it helper, open up the parentheses. We're going to say underscore s colon. That's going to be a string. Come underneath that, say comma, then we're going to say underscore n colon. That's going to be an integer, and it's going to return a string just like that. Boom. Then we can open up the brackets. Now we need to handle the base case if n is equal to 1, and we could just return the current string similar to example 2. So we can come right here, we'll say guard n is greater than 1, else we could just open up the brackets and return s. Boom. Now we need to create our resulting string, which for the current step that will be on as in our code. So we could declare a variable, we could call it string, and we could just set that equal to a blank string just like that. Then we need to create a variable to track the previous character. So in order to do that, we could declare a variable, we could just call it prev, and we'll say colon, that's going to be, and say character, and we can put a question mark at the end. Now we need a variable to count the consecutive occurrences of the same character. So to do that, we could just say var count. Then we'll say colon. That's going to be an integer. We could set it equal to 1 to start as our default value. Boom. Now we need to iterate over each character in the input string. So we could say for C in S, we're going to open up the brackets. Then we're going to say if let prev equals prev, we're going to open up the brackets. Then we're going to say if C equals prev, we're going to open up the brackets. Boom. And if it's the same as the previous character, we can increment count. So we can say count plus equals 1. Boom. Then we come right here and we can say else. We're going to open up the bracket. If the character changes, we need to append the count and previous character to the result. So we'll say string plus equals. We're going to use some string, plus equals. We're going to use some string interpolation for this so we can append the count and previous character. So in order to do that, we're going to open up the quotation marks for the string. We're going to say slash parentheses count, close the parentheses. Then we're going to do the same thing for prev. We're going to say slash parentheses. That should be a slash parentheses prev. Then we're going to close the parentheses. Then we need to reset the count for a new character. So we're going to say count equals 1. Boom, to reset it. Not plus equals, we're resetting it, so just equals. Boom. Now we need to update the previous character. So to update the previous character, we come outside of this if let, and we can say prev equals C. Now after the loop, we need to append the last counted group. So to do that, we're going to come outside of this for loop, and we are going to say string plus equals. So we're going to do the string interpolation again. Open up the quotation marks. We're going to say slash parentheses count, close the parentheses, slash parentheses prev. Then we can put exclamation point, close the parentheses. Boom. Now we need to use the recursion with the new string and decrement n. So to do that, we're going to come underneath this. We're going to say return helper. We're going to open up the parentheses. We're going to say string, comma, n minus 1. Boom. And now that's it for the helper function, right? Remember, all of this right here, that's in the helper function. So now we need to return and call it in the main function. So this is going to start the recursion with the initial string of 1, and the target level will be n. So in order to do that, we're going to say return helper, open up parentheses, quotation marks 1, come outside the quotation marks, we'll say comma n. Boom. Now that should be all she wrote, y'all. Let's go ahead and give it a run before we submit it. Make sure it runs properly. Ooh, look at that. And it's accepted first try. So let's go ahead and submit it. Let's go ahead and submit this Let's see. Ooh, 2 milliseconds beats 80% of users. We could get that up, but that's not too bad. Not too bad at all, y'all. So, with that being said, y'all, make sure you get one more look at the code. That's the top of it. That's the top part. Boom. That's the bottom part right here for you. Read it, learn it, love it, internalize it. Make sure you understand what's going on. And yeah, with that being said, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.